Hello students, today we are going to discuss about that one topic related to mechanics, and that is fluid mechanics. So in that lecture basically we will discuss about that surface tension of liquid and also about that Archimedes principle. So we'll start with surface tension. Okay. So what is surface tension? Surface tension is nothing but it is the property of liquid in which liquid itself try to minimize its surface area. Okay, because to reduce the surface energy. So surface tension is nothing but is the property of liquid in which it try to minimize the surface area. Okay, to minimize the surface area means to minimize the surface energy. So I can write it is the property it is the property of liquid. The property of liquid to the minimize the surface area. Hmm? And the term minimize the surface area, minimize the surface area. This term or this statement, minimize the surface area, is important because minimize the surface area means minimize the surface energy. Okay. So it is clear from that basic classical mechanics that every system want to stay in stable position. Okay, every system in nature they will try to stay in minimum energy position or in stable position. Okay, so to achieve the stability of a system, it has energy should be minimum. Hmm? This is the necessary condition to achieve the stability. Okay, so every system in nature want to stay in stable condition or in stable uh, configuration, and for that the energy of the system should be minimum or ground state energy, and that energy will be minimum in case of liquid when the surface energy is minimum, and the surface energy is minimum when the surface area is minimum. Okay, so this is an important point that every system in nature want to stay in stable condition, and for that the energy of the system should be minimum. In case of liquid, that can be possible when the surface energy is minimum, and that is possible when surface area is minimum. Okay, so it is we already have observed that if I take like uh, raindrop raindrop then the shape of this raindrop is actually spherical. Okay, why? Because because for a given volume, if you have a given for a given volume, the surface area will be minimum for spherical shape. So for a given volume, the surface area will be minimum. Okay, when shape is spherical. Okay, it means the spherical liquid or spherical shaped liquid will have minimum surface area. It means it has minimum surface energy. So it means basically I can conclude that spherical shape is having minimum energy or lowest energy. Okay, so to achieve the stability of liquid drop, it has to take that shape that is spherical, that is observable, that is, I mean, automatic process. That liquid drop is having spherical shape. To achieve that stability, the shape should be spherical because of minimum surface area, and minimum surface area will give you minimum energy, and that is actually stable configuration. Okay, that's why liquid drop or raindrop is to take spherical shape. But you can see some exceptional case, like suppose you have a table surface. You have a table. This is your table surface. If you keep a water drop, the shape is no longer be spherical, but rather it will take this kind of shape. If you have a table surface, if you keep a water drop here, the shape is no longer be spherical, rather the shape will be like this. Hmm. Why? Because of its weight that is acted downwards. So this is no longer be spherical, but the shape is like this because of this mg. Because of this weight, the shape is actually exceptional, or this is actually exceptional case. Why? Because that gravity or weight actually acting downwards, and that actually deform that shape from spherical to kind of this. Okay. Now how will define that surface tension actually? So suppose you have a liquid surface. You have a liquid surface. Okay. This is your liquid surface. Hmm? And you have a drawn a imaginary line. The imaginary line. So this line is actually on the surface of liquid. Okay. And let us assume the length of this line is L. Then there will be force will act on both sides. There will be force act on the both side on this line. And that angle between this force and this line, that angle will be how much? That will be 90 degrees. So the definition of surface tension T is your surface tension. Okay. So this is defined as force acting on this line per unit length. So you have an imaginary line, you can think like a thread. You can think like a thread having length L. Force is actually acting both sides. You kept this thread or imaginary line on the surface of liquid. Force is acting on the both side, and that is actually perpendicular to the length. So definition of surface tension T is nothing but force per unit length. So of course that unit of surface tension will be Newton per meter. But this thing is not important. The important thing is total force acting on the thread, that will be nothing but surface tension time L. So this much force is acting on both sides, this side also and this side also. So on both sides, the force is actually T into L. Okay. So if someone asks you how much will be the net force on this imaginary thread or imaginary line, so net force will be 0. But in the exam point of view, they will not ask you net force, rather they will ask you force acting on this thread. So force acting means they are asking a force acting on each side, that is how much. Okay. So net force will be 0, but on each side that force amount will be how much? That will be T into L. Okay. Now let us solve a problem. Okay. So suppose you have a beaker, or rather I'll think like a glass having this kind of shape, cylindrical shape. You have a glass, and inside glass there is a liquid, or basically there is a water. Okay. This glass is filled with water, having surface tension of this water is given, and that is also important, 0.075 Newton per meter. Okay. The radius of this glass is given, cylindrical glass actually. The radius is given, that is 15 centimeter. Hmm? So the question is, how much will be the net force acting on the imaginary diameter on the surface, on the surface of liquid or water. So you have a cylindrical shaped glass that is fully filled with water, having surface tension. This number is also important, 0.075 Newton per meter. The radius of this cylindrical shape glass is given, that is 15 centimeter. Okay. So the question is, how much will be the net force, not net force, how much will be the force acting, how much will be the force acting on the imaginary diameter of the surface of liquid or water. Basically not liquid, this is basically water. So net force acting on imaginary diameter of liquid surface, so that will be how much? So very simple. So if r is this much, so imaginary diameter means net length, that will be how much? 2 times r, and that will be simply 30 centimeter. Okay. And I know that force acting. Okay. So net force will be 0, but they will not ask you like that. They will ask you force acting on each side. That will be how much? So that will be T into L, and T is given, that is 0.075 Newton per meter, and L given in centimeter. So I'll convert it into meter. So it will be 30 into 10 the power minus 2 meter. So that you have a surface tension given in SI, and I have converted that length in meter, so that force unit will be what? This will be Newton. Okay. So if you calculate this value, basically you will get 22.5 into 10 the power minus 3 Newton. Okay. Okay. So you have a cylindrical shaped glass completely filled with water, having surface tension 0.075 Newton per meter. So force acting on the imaginary diameter on the surface of water will be nothing but T into L. L will be the diameter length, that will be 2 times radius. And every parameter is given. If you put, you will get the value that force acting on each side, that will be 22.5 into 10 to the power minus 3 Newton. Okay. Now next you have liquid film. Next you have you have liquid film. Okay, so it is very important to understand or to keep in mind that the liquid film, irrespective of composition, whether it is of thin film of water or some other liquid drop or mercury or alcohol, whatever it is, if it is liquid thin film, hmm, if it is liquid thin film, irrespective of composition like soap or water or air bubble or mercury, whatever it will always have two layers, two layers or two surfaces, two layers or two surfaces. Hmm? It will always have two layers or two surfaces. They are very close to each other. That is also important. They are very close to each other. Okay. So you have a liquid thin film. It will always have two surfaces. In general, we think that liquid surfaces, or you have a surface that is having only one surface or one layer. That is not true. If you have a liquid thin film, it will always have two surfaces or two layer, two surfaces or two layer, and they are very close to each other. So surface tension that will be happen due to two surfaces, not only single surface. So if I have suppose this kind of shape, and you have a liquid, you have a liquid, filled liquid. This is the liquid. The liquid, and you have a sliding wire. You have a sliding wire. You have a sliding wire. This is the sliding wire. Sliding wire or thread. Let us take wire having length L. You have a sliding wire having length L. Okay. So if because of surface tension, this sliding wire or length that will there will be. So this problem is very simple. You have a liquid and you kept a sliding wire on the surface of this liquid. Okay. So because of surface tension, there will be force acting on this wire in this direction. There will be force acting on this wire in this direction, right? Because of surface tension, and that force I have denoted by F. And let us assume that T is the surface tension of this liquid. T is the surface tension. T is the surface tension of this liquid. Okay. So you have a important, what is important thing? You have a sliding wire that is kept on the surface of liquid, and because of surface tension, there will be force acting on this wire, and that is in this direction. Okay. But if you write that force we already know that is nothing but T into L. That is actually wrong, because for thin film, this is a kind of thin film of liquid. This is a kind of thin film of liquid. Okay. So, and on the thin film, you have a two layers. You have a two layers or two surface. Each surface will, each, because of each surface, there will be force amount that is 2L. Sorry, TL. So each surface is producing TL amount of force. Each surface is producing TL amount of force, or that sliding wire is experiencing TL amount of force due to single surface. Sliding wire is experiencing TL amount of force due to single surface, but you have a thin film. There are basically two surface or two layer. So for each surface, it is experiencing TL amount of force. You have a two surface, so obviously net force will be 2 into TL. That is very important actually. If you keep the TL, it is actually wrong. So whenever you have a thin film, you have a sliding wire. So net force acting on the sliding wire is nothing but 2 times surface tension into length of sliding wire. And 2 is arising because of it has 2 layers or 2 surface. That's important actually. Suppose you have a U-shaped container. You have a U-shaped container where you kept liquid. Okay, you kept that liquid, and there's a sliding wire. This is your liquid. Okay, and you have a sliding wire. Okay, length is given of this sliding wire. The length of sliding wire is given, and that is 30 centimeters. So on the surface you have a sliding wire, and the length of sliding wire is given, that is 30 centimeter. Okay, so this sliding wire can support a weight. It can support a weight, and that weight is given, that is 1.5 into 10 to the power minus 2 Newton. This you have a sliding wire that is kept on the surface of this liquid. So this is a kind of thin film liquid. On the surface you kept sliding wire, length is 30 centimeter, and it can support that weight, that is how much? That is 1.5, that is 1.5 into 10 to the power minus 2 Newton. What is the meaning of support? It means because of this force, there is a downward force, right? Because of this weight, there is a downward force. And that downward force is how much? That is nothing but 1.5 into 10 to the power minus 2 Newton. So support means that this sliding wire is experiencing a force, or due to surface tension, it is experiencing a force, and that is actually acted opposite to the direction of W. You have a W that is acting in the downward direction, and because of surface tension, there is a force that is upward direction. So what is the meaning of support? Support means that this net force on the sliding wire is 0. Net force on the sliding wire is 0, and so basically I can write W. W will be balancing with that upward force, and upward force is arising because of what? Because of your surface tension. Okay, so the question is that it can support this much weight. It can support this much weight. So you have to calculate the surface tension of this liquid. So you have a U-shaped liquid, U-shaped container where there is a liquid or thin film liquid is kept. Okay, and it can support a weight that is 1.5 into 10 to the power minus 2 Newton, and the length of sliding wire is given 30 centimeters. So you have to calculate the surface tension of this liquid. So very simple. There's a two force they are balancing. One is due to weight, that is acting downwards, and that force is given, and that is perfectly balancing with force due to surface tension, and that is acting upwards. So support means basically what? It is the meaning that both forces are equal, or I can say that motion of this sliding wire is 0. The meaning of support is that. So I can say that W is balancing with the force that is due to surface tension, and that force, you have a liquid thin film, so obviously that force will be 2 into T into L. It means T will be how much? W by twice L, and W is given 1.5 into 10 to the power 1.5 into 10 to the power minus 2 divided by 2L. 2L means 60 centimeter. So if I convert it into meter, it will be 60 into 10 to the power minus 2, and obviously that unit will be what? It will be Newton per meter. So if you calculate this number, I have calculated, you will get basically 0.025 Newton per meter. Whenever you have a thin film, so net force is no longer TL, rather it will be 2 times TL because of two layers. Okay, and some important properties about that surface tension. Important points about surface tension. Okay, so if you mix that soap with water, if you mix that soap with water in a water, then or if you mix the soap in a liquid, that then the surface tension of that liquid will be decreased. And because of this decrement of surface tension of liquid, it can reach, that liquid can reach or water can reach on the whole of cloth, and it can clean that. Okay, so if you mix that if you mix that soap in a water, the surface tension of water will be decreased, and due to this, that soap mix water or soap water can reach the whole of that cloth and it can clean. Hmm? That's why you use that soap. Okay, so if you mix that soap, then surface tension of water will decrease. Okay, second point, if you increase the temperature, if we increase the temperature of liquid, if we increase the temperature of liquid, then surface tension surface tension surface tension will decrease. Hmm? So if we mix the soap in a water, then surface tension will decrease, and that's why you used to take soap to clean our cloth. And second, if you increase the temperature, then also there will be decrement of surface tension of liquid. So it's an important point about that surface tension. Now, one is about that surface energy. If I talk about that surface energy, that is also important point. So surface energy, and this is basically denoted by U. Hmm. So suppose you have a container having liquid. Inside container there is a liquid. There is a liquid. The molecule that is properly inside that liquid, let us take this molecule that is properly inside that inside the liquid. Okay, that is inside that liquid is attracting from all side with other molecules, right? So it will, if it is having potential energy is like minus U. So you have a molecule that is properly inside that liquid, it is attracting by other molecule from every side, and because of attractive nature, I can write that potential energy that will be minus U. So if the molecule that is properly inside that liquid, if the molecule has having potential energy minus U, The molecule lying on the surface, let us take this molecule. It is only attracting from one side. If I take like a square, like a sphere, only half of the portion of the sphere that is attracting, only half of the portion of the sphere that is attracting this molecule. It is not attracting from every side, rather it is only attracting from half of the portion. So obviously, if the molecule is having inside the liquid, if it is having potential energy like minus u, the molecule on the surface that is only attracted by some of the molecule, the potential energy of this molecule will be minus u by 2. So the molecule on the surface, it will have higher energy. It will have a higher energy as compared to molecule that is properly inside that liquid. That surface energy, so if I define that surface energy, and that will be proportional to the surface energy of a liquid, that will be proportional to the number of molecule on the surface of nucleus, sorry, of the surface of on the surface of liquid. So आपके पास जितना ज्यादा नंबर ऑफ मॉलिक्यूल ऑन द सरफेस होगा, उतना ही आपका सरफेस एनर्जी बढ़ेगा। क्योंकि जो मॉलिक्यूल सरफेस पे लाई करता है उसका ज्यादा एनर्जी होती है एज कंपेयर टू मॉलिक्यूल properly inside that liquid. So जितना ज्यादा आपका मॉलिक्यूल सरफेस पे होगी, उतना ही ज्यादा आपका सरफेस एनर्जी होगी। एंड जितना ज्यादा सरफेस एरिया होगी आपका लिक्विड का, जितना ज्यादा सरफेस एरिया होगी, उतना ही ज्यादा आपका number of molecule on the surface होगी, है ना? So what I can say, the number of molecule on the surface of liquid depends upon the surface area, है ना? So obviously the surface energy will be proportional to surface area. Now if you remove that proportionality constant, you will basically get T into A. Now if I this equation I can also write that delta U equals to T is some constant, that is surface tension properties of liquid, that will be constant, and I can write it will be delta A. So change in surface energy, change in surface energy, that will be proportional to change in area. So surface energy number of किसके ऊपर डिपेंड करता है? नंबर ऑफ मॉलिक्यूल ऑन द सरफेस। और नंबर ऑफ मॉलिक्यूल ऑन द सरफेस किसके ऊपर डिपेंड करता है? सरफेस एरिया के ऊपर। जितना ज्यादा सरफेस एरिया होगी, उतना ही ज्यादा अपना का सरफेस मॉलिक्यूल होगी, और जितना ज्यादा सरफेस मॉलिक्यूल होगी, उतना ही आपका सरफेस एनर्जी बढ़ेगी। It's a really important formula, and from here I can derive delta U, change in surface energy, that will be depends upon change in surface area. Now suppose you have a liquid film. Suppose you have a liquid film. You have a liquid film, and there's a sliding wire having length L. There's a sliding wire having length L, and T is the surface tension of liquid. Is the surface tension of liquid. So because of surface tension, there will be force, that will be F. Now what you have done, you have applied external force this side. and you displace this sliding wire by an amount of x. You displace this sliding wire by an amount of x, and you have applied for this, you have applied external force. And this process is happening very slowly. Process is happening very slowly. Process is happening very slowly. So how much will be net work done by external to displace this wire from by an amount of x? So this work will be nothing but F into x, or better I'll write F external into x, F external into x, because work done is nothing but force applied into displacement, and force applied is how much? That is external force F. And remember, this process is happening very slowly. So what is the meaning of very slowly? If you done this process, or if you displace this sliding wire at a very slow rate, it means at every situation that force due to surface tension that is matching with or making balance with external force. So this force F is basically due to surface tension. So in that process is happening slowly. So at every moment that external force is actually balancing with force due to surface tension, and I know force due to surface tension for thin film, that is nothing but 2 into 2 into TL, right? 2 into TL. So that work done WEXT, work done by external agent, I can say that will be nothing but 2 into T into L into X. And work done is nothing but, I know work done is nothing but change in potential energy. Change in potential energy, and that will be nothing but T into 2L into X, and that I can write T into WA, sorry, T into delta A. So total work done in this process will be nothing but surface tension into delta A. Delta A is what? Delta A is total change in area. So change in area of change in area of there is basically two surface. There is basically two surface on that liquid thin film. So for each surface, the change in area will be how much? That will be L into X. So total change in area in the process, that is you have two surface, so that will be L into X plus L into X, that will be 2LX. So delta here representing the total change in area. Okay. So this process this is also important. Suppose you have a spherical bubble. So before doing problem, let me discuss one more thing that is also important. So if you have a bubble, if you have a drop or bubble, if the bubble is having soft, अगर bubble आपका soft है, then only it will have two surfaces. Then only it will have two surfaces. ना? आपका कोई ड्रॉप है या बबल है, बबल अगर सॉफ्ट की है, देन इसका दो सरफेसेस होगी. तो बेसिकली सॉफ्ट फिल्म हो या सॉफ्ट बबल हो, उनके पास आपका दो सरफेसेस होती है या दो लेयर होती है. बट यू हैव बबल लाइक वाटर और मर्करी और अदर, राइट? you have a bubble like water, mercury, है ना, and anything other, then they will have only on surface. So drop या bubble है ना, अगर आपका soft की है then it will have two surfaces, but for other drop or bubble like drop of having mercury or liquid water, then it will have only on surfaces. Now suppose you have a spherical bubble, है ना, you have a spherical bubble, its radius is r. You have a spherical bubble, its radius is r. Okay, is a problem. You have a spherical bubble having radius r. Now we are increasing the radius of this soft bubble. This is a soft bubble. Huh? This is your soft bubble. Soft bubble. Now you are increasing the radius of this soft bubble from r to 2r. You are increasing the radius of the soft bubble from r to 2r. Then how much will be the work done in this process? How much will be the work done in this process? So that basically you can calculate, right? So we know that work done is nothing but T into surface tension into change in area. And T is the surface tension and change in area. The change in area will be how much? So you know that sphere is having area that is 4 pi r square. So final area is how much? Change in area means final area minus initial area. So final area will be how much? 4 pi into 2r square, because your radius is how much? 2r, and then minus initial area, that is 4 pi r square, because initial radius was r. But there is some problem, because total change in area is not like this, because in if you remember, you have a soft bubble, right? Soft bubble having two surfaces. So this is the change in area of single surface, but you have two surfaces, so total change in area will be how much? That will be 2 times. So for single surface you will have change in area like this, but remember delta A is not like a change in area of one surface. This is the total change in area. So total, if you have two surfaces, the total change in area will be change in area of single surface multiplied by 2. So this will give you total change in area, and if you calculate this number, you will basically get 24 T pi r square. So this much work you have to done to increase the radius of soft bubble from r to 2r. And this work done is in terms of surface tension. They will provide you that surface tension, and they will ask you how much will be the work done is or can be done to this process. Okay, so you have to keep in mind, if you have a bubble or drop for soft, or you have a thin film of soft, it will have two surfaces, but thin film of others will have two surfaces, but thin drop or bubble of other except soft will have one surfaces, except soft will have two surfaces. Okay, okay. Okay, now you have another thing, that is your excess pressure. That is also important. Excess pressure. Except excess pressure. Suppose you have a liquid drop, you have a water drop, you have a water drop, and let us assume r is the radius of this water drop. So there is a you have outside this drop, there is an atmosphere, right? And atmosphere is giving, or outside pressure is giving, there is an atmosphere. Due to this, there is a pressure acting inside innerwards towards the center of this, water drop. So on inner odd pressure, that is due to from atmospheric pressure, or outside pressure, that is actually acting outside pressure, that is actually acting towards the center of this water. Another force that is acting, and that is your basically what? Surface tension force. But this liquid drop is stable because there is on inner odd force. Inner odd pressure is basically acting away from this inner odd pressure, acting away from the center, and that is actually balancing with outward pressure acting towards the center, and also surface tension that is acting towards the center. So basically, I can write, because of the stability of this liquid drop, you have a inward pressure, that is P in, that is actually acting away from the center, that actually balancing with outward pressure, and you have a surface tension. So you have to always keep in mind that actually inner pressure acting away from center, that is balancing not only outward pressure due to atmospheric pressure, that is acting also surface tension. This is balancing both actually, and that makes your liquid drop stable. So since you have a water drop, so surface tension of this water drop will be how much? That will be, this is your P out, and this will be your basically 2T. T is the surface tension divided by R. When you have a water drop. So excess pressure is defined as delta P, that is nothing but P in minus P out. Okay, P in minus P out, and for water except for drop except sub bubble, and if I take like water, so what I'm saying that excess pressure for drop except sub bubble, for example water, and that pressure will be how much? 2 times surface tension divided by a radius. Okay, now if you have sub bubble, if you have sub bubble having radius r, so again you have a atmospheric pressure, that is outside pressure, that is acting towards the center of this liquid, or sorry, center of sub bubble, and also you have a surface tension. So remember, there are basically two surface, so each having surface tension value 2T by r. 2T by r. So net surface tension is here how much? That is your 4T by r. 4T by r arising that pressure because of surface tension, and outside pressure, that is atmospheric pressure. So both these two pressure is actually balancing with P in pressure, that is acting away from that center. So for sub-bubble case, you have a inside pressure P in actually balancing with outside pressure P out arising because of atmosphere, and you have a surface tension. But remember, you have a two surface, so net surface tension pressure will be how much? That will be 4T by R. So it means excess pressure delta P will be how much? P in minus P out, and that will be 4T by R. This is for top bubble. So T is surface tension and R is radius. So this is your excess pressure, that is 4T by R. And that is because of what? Because of surface tension. Okay. Now suppose you have another important part, and that is actually in JAM they may ask this question from here. You have a upthrust force. Upthrust upthrust or buoyancy force. Buoyancy force. And that is basically Archimedes principle. Archimedes principle. You have a upthrust or buoyancy force or basically Archimedes principle. So suppose you have a liquid. Suppose you have a liquid. The density of this liquid is rho L. And suppose a solid can have any shape. Let us take, for the sake of convenience, let us take a solid having cylindrical shape. And A is the surface area. A is the surface area of this cylinder. A is the surface area of the cylinder. Rho S is the density of this cylindrical solid. Okay. And L is the total length of this solid or cylinder. And ms is the mass of this cylinder. So you have a liquid having density rho L. Inside liquid, you have a solid having cylindrical shape. Total length of this cylinder is L, mass is ms, density is rho S, and area of cross section is A. And let us assume that h length of this solid cylinder is submerged. H length of this solid cylinder is submerged inside this liquid. Okay, so there is a on force acting opposite to the gravity, and that force is basically called upthrust force U. That will be nothing but A, that is the area of cross section of solid, into height of the solid that is submerged inside liquid into density of liquid into G. So A into H, area of cross section into H, that will give you the volume, into rho of L, that is the density of liquid, and G is the gravity. So here V is what? V is volume of solid inside liquid. Volume of solid inside liquid, or I can say V is nothing but volume of displaced liquid. Volume of displaced liquids. So it's obvious. So volume inside liquid means volume of solid inside liquid, that is how much? This much, that is A into length submerged inside liquid. So when it occupy this much volume, of course, that solid displace how much volume? Volume of liquid, that will be V, right? So what I'm trying to say, when V amount of volume of the solid is come inside that liquid, obviously it will displace that much volume of liquid. So upthrust force is nothing but V, that is the volume of solid inside liquid or volume of displaced liquid. Same thing, right? When it come inside that liquid, it will displace how much volume? That will be your V. And volume of displaced liquid into density. We know this formula, right? Volume is nothing but mass per unit density, or density is nothing but mass per unit volume. So mass is basically rho into V. So what I can say that upthrust force will be mass M into G, where M is what? Mass of displaced liquid, mass of displaced liquid. So when solid is submerged, the volume that is V inside liquid, it will displace the volume of liquid, that will be V. And V into density, that will be the mass of displaced liquid. So M into G, M is the mass of displaced liquid. Okay. Now when this solid come inside that liquid, and there is an upthrust force against that gravity. So the net weight of this solid when it is inside that liquid, that will be apparent weight, apparent weight that will be smaller than actual weight. So when that solid inside liquid, it will have smaller weight as compared to its actual weight. So apparent weight will be the weight of this solid, in air minus upthrust. Okay, weight of this solid when it is inside, some of the portion of the solid is inside, then apparent weight will be weight of the solid. This is the weight of solid in air minus upthrust. So weight loss, they may ask you weight loss. Weight loss of the solid will be how much? That will be nothing but upthrust. Okay. And if suppose this solid is inside by an amount of h length. Now this, if this solid is or cylinder is basically achieve that equilibrium condition. If the solid is achieved equilibrium condition, when the height of the solid or when the length of the solid inside the liquid, that is h. If this solid achieve that equilibrium condition, it means that actually mg is balancing with upthrust force. So at equilibrium condition, net force acting on this solid, that will be mg minus u, that will be 0. So if the solid achieves equilibrium, at equilibrium condition, net force will be 0. Okay. Okay. Now let us solve one or two problems, then we'll stop it. Okay. So suppose it is given you have a container in which liquid is there. Okay. And the density of this liquid is given, that is 800 kg per meter. A cylinder okay, mass of this cylinder is given. That is 0.4 kg, 0.4 kg, and density of this cylinder is given. density is 1600 kg per meter cube. Hmm. So you have a liquid inside liquid, only 1/5 portion or 1/5 volume of this cylinder is inside liquid. 1/5 volume of this cylinder is inside liquid. Mass of this cylinder is given 0.4 kg. Density of cylinder is 1600 kg per meter cube. Density of liquid is given 800 kg per meter cube. And you have to calculate the upthrust force. So upthrust force is nothing but volume of cylinder inside liquid, and then density of liquid, and then G. Okay. So this is the volume of cylinder inside liquid. So that actually I can calculate. Better I'll use the different symbol. Let us take that is V dash is the volume of cylinder inside liquid. And it is given that 1/5 of total volume of cylinder inside liquid. So V dash will be how much? Total volume of cylinder divided by 5 into density of liquid into G. So first of all, they didn't give you that volume of cylinder. So, but they have given that mass and density of cylinder. I can calculate the volume of this cylinder from this parameter itself, because I know volume is nothing but mass per unit, mass of cylinder divided by density of cylinder, and mass is given, that is 0.4 divided by 1600. So if you calculate, I'll get 1 by 4000. I'll get 1 by 4000. So now this is the total volume of your cylinder. So upthrust force will be 1 by 5 into 1 by 4000 into density of liquid, that is 800, and gravity 10. So if you calculate this, basically you'll get 0.4 Newton. Okay. So this kind of question very trivial, and they may ask how much will be the upthrust or how much will be the apparent weight. So apparent weight, it will be nothing but upthrust, sorry, total weight minus upthrust. So if I calculate that apparent weight here, how much we'll get? So apparent weight will be how much? So actual weight, that is nothing but ms into g minus u, right? So ms into g, ms is how much? 0.4, and g is 10. 0.4 into 10, that is 4 minus how much? 0.4. So this will be 3.6 and of course Newton. So they may ask you apparent weight or weight loss by giving this kind of parameter, and it's an important and trivial question. Okay. So I think we can stop here and we'll further discuss other things.